Hello friends, how are you? Today in this video I am going to talk about reaction mechanisms. What is mechanism of reactions? You know my friend, you can see some reaction is fast, some slow. So step by step reactions or step by step description of the reactions is known as mechanism of the reaction. Information about the position, shifting and moment of electrons in bond. So detailed reaction mechanism cannot be elucidated, only the proposed mechanism that is put forward, energetically reasonable, account for experimental observation in agreement with what is known about analogous reactions. So method adopted for determining the reaction mechanism of a reaction: isotope labeling technique, stereochemical evidence, crossover experiment, identification of product, identification of reaction intermediate. So isotopic labeling technique. In this method, a single atom of any chemical compound is replaced by its isotopes. For tritium, deuterium, carbon-13, carbon-14, nitrogen-15, oxygen-18 are the most common isotopes which are frequently used. So you can see the ethyl acetate, it gives acetic acid in ethanol. When you label oxygen 18, then acetic acid and ethanol, acetic acid contains oxygen 18. And alkyl oxygen, if you are using acetic acid and ethanol, so ethanol have the 18. So this 18 actually coming from the water. So stereochemical evidence. Stereochemistry of the reactant and the product. Optically active substrate, optically inactive product, racemic mixture, SN1 mechanism. Optically active substrate, optically inactive product, and inverted configuration, Walden inversion, SN2 mechanism. You know that. So SN1 reaction, you know that. Hydrolysis of ethyl bromide. Now crossover experiments. To study the mechanism of molecular rearrangement reactions, intramolecular rearrangement or intermolecular rearrangement. Two non-identical reactants differ by one characteristic group. So you can see Fry's rearrangement. Here OCOCH3 and you have the another one. In presence of anhydrous intramolecular mechanism, you can see the formation of alcohol, and intermolecular mechanism you have the formation of alcohol with the two products. So identification of the reaction intermediate. Reaction intermediate are an important class of chemical species which are quite helpful in understanding the mechanism of chemical reaction. Like isolation, उसको निकाल सकते हैं, detections और पकड़ सकते हैं, trapping. Isolations कैसे करेंगे? These species by nature are unstable under normal reaction condition, but they can be isolated under the favorable conditions, either in the pure state or in the form of solution. The Hofmann rearrangement like amide give amine, formation of isocyanate intermediate and isolation of isocyanate intermediate. Now Hofmann bromide reaction, you can see the formation of RNH2 with the amide, CONH2 converted into RCONH-BR, NHBr further reaction it gave the RCON minus Br, and that is the rearrangement formation of isocyanate, and then isocyanate converted into RNHCOOH, and then CO2 it give RNH2. So stable intermediate, long life, high concentration detected by isospectroscopy method. Fun fact: George Olah of California University got the Nobel Prize in 1994 for his work on cation. He was able to prepare a number of stable long-life carbocation and recorded their carbon-13 NMR spectra. Now trapping. Intermediates that are not capable of being isolated as they are not quite stable or quite low in concentration are characteristic by trapping them with a suitable reagent, and this reagent form product with the intermediate which are particularly characteristic of the species. Now base promoted solubilisis of chloroform when carried out in the presence of cyclohexene or dicyclocarbene is trapped and an adduct cyclopropane derivative is obtained. You can see So, identification of product, basic framework, reactant, intermediate product, elucidation of the reaction mechanism, identifying intermediate, very short lifetime, low concentration, UV, IR, ESR, proton NMR, carbon 13 NMR, and mass. So, the reaction of orthochlorotoluene with a strong base not only gave the expected M-cresol but also the unexpected orthocresol. The formation of both the product can only be explained by the formation of benzene intermediates. So, this is the reference, Advanced Organic Chemistry by Jagdamba and Dr. Yadav, Conceptual Organic Chemistry by Arun Sethi. Thank you.